As a part of indexing, I like to call index attributes. Why do I call them attributes? Essentially, these things I call index attributes are really extensions of index types, or they could be called index types as well. They're really variations on mainly B-tree indexes. B-tree indexes are the most important and most commonly used indexes in Oracle, particularly for any kind of OLTP, client-server, highly active transactional application database. You need to use mostly B-trees. Most of the other types of indexes are more applicable to read-only data warehouse type functionality, although that is not essentially 100% true, but most often it is. So what are ascending or descending indexes? That's basically an ascending index is an index that's organized from A to Z, and a descending index is organized from Z to A. As you can see here, we've got oldies beginning with O and ending with world music. And there we've got world music at the top and oldies at the bottom. Uniqueness. Uniqueness really applies in terms of a column must always be a unique value across a table. In other words, you cannot put a customer name into a table which already exists. You cannot have two customers with the same name or two entries for the same customer. That's what uniqueness ensures. Composites. What is a composite? A composite index is a composite or concatenation of multiple columns. So here we have a row ID, and then we have an index on the country, the state, the city, and the venue. So you have an index across all these four columns. This leads us to compression. This is another variation on an index which allows us to compress the values in the index. In other words, remove the duplicates. That's really what it does. So in the diagram here, you see we've removed every entry of USA except one. Since all our venues are in California, we've removed everything but California. And then we've removed all the duplications of the city. So the first two rows would be Modesto. The second 3, 4, 5, 6 rows would be Monterey, etc. Compression allows your index to be a lot smaller, although there is an overhead when searching this index in order to reconstruct the values that are in there. That's probably negligible though. I've never noticed any problems with it. Reverse key index. A reverse key index is literally reverse the key. So as you can see, 23 changes to 32. You're reversing the values in the index. Note, you do not reverse the row IDs. The row ID is still an address. You can't change that around. If you were to change the row ID and make that appear in reverse, you'd never find the record. When creating an index, there's an option called no sort. All it does is it doesn't sort the index in the order of the index. In other words, it will create the index in the order in which it's read from the table. If you read the table without an index, another index that is, you create an index in the physical order that the data was inserted into the table. This can have its uses. Null values. Strange behavior with indexes. Not really, if you think about it. Null values are not included in indexes unless they're subset parts or subset columns in composite indexes. Why would you include multiple values in an index? First of all, if you have a unique index, you can't put null values into it because they're duplicates. It wouldn't allow it. This is why primary keys and unique indexes do not allow null values. So, you would not include a null value in an index because you can't find anything with it anyway. It's nothing. There is no related table entry for it.